How's it going, everyone? This video is about the unit circle and how it can be understood through the use of special triangles. So the unit circle is a circle with radius 1, and it is centered at the origin of the x and y axis. So the coordinates of this point here are 1, 0. This top point here, 0, 1. The point on the left side here is -1, 0, and the point at the bottom is 0, -1. Now you can select a point anywhere along the unit circle and draw a line from the center of the circle, which is also the origin, to that point at the edge of the circle. That line is going to have a length of 1 because the radius of the unit circle is 1. Now you can also define an angle as being the angle from the positive x-axis to that line. We're going to call that angle theta. And from that point on the edge of the circle, you can also draw a line straight down to the x-axis or straight across to the y-axis, and that forms a triangle. And it's actually the same triangle whether you're drawing a vertical line to the x-axis or a horizontal line to the y-axis. It's just the same triangle upside down. And the base of that triangle is actually the x-coordinate of that point, and the height of the triangle is the y-coordinate of that point. And how that relates to this angle theta is that x is equal to the cosine of theta and y is equal to the sine of theta. That is how cosine theta and sine theta are defined. They are just the coordinates of points along the unit circle. That's why, for example, if you have an angle which enters into the top left quadrant, okay, so let's say that's your angle here. Well, that angle, the sine of that angle is going to be positive because your y value is positive, and the cosine of such an angle is going to be negative because your x coordinate is negative. Now there's infinitely many points you can select along the edge of the unit circle, right? So there's infinitely many of these triangles that you can create, but certain points along the unit circle are considered special because they create certain special triangles which have nice, easy, convenient numbers as their angles and their side lengths. So we're going to go through those special triangles and those special points along the unit circle. There's only 2 of them. Only 2 of those special triangles. So let's get to the first one. Okay, how you get the first special triangle is if you have an angle of 45 degrees. Okay, so imagine a triangle with side length 1. It's a right angle triangle, and this angle here is 45 degrees. Well, that's an isosceles triangle, okay, because it has 2 equal sides and 2 equal angles. This angle here also has to be 45 degrees because all the angles of a triangle add up to 180. And if we do 180 minus 90, which is the 90 right here, minus 45, which is the 45 right here, we get 45, right? So this angle is also 45 degrees, the top angle there, right? So you have an angle with triangle with 2 equal angles, which means these 2 sides are also equal. All right, so let's call it side A. All right, so by Pythagorean theorem, a squared plus a squared equals the hypotenuse, which is 1 squared. So 2a squared equals 1. A squared is 1 over 2. So a is the square root of 1 over 2, or 1 over root 2. Now, some people consider it bad form to have a root in the denominator. Personally, I don't have a problem with it. But how to get rid of that root in the denominator? Just take this fraction and multiply it by root 2 over root 2. You can do that because you're just multiplying by 1. Anything times 1 is itself. Root 2 divided by root 2 is 1. So at the top you get root 2, at the bottom you just get 2, because root 2 times root 2 is equal to 2, by definition. The square root of 2 is something that, if you multiply it by itself, you get 2. So that's our special triangle. Okay. Hypotenuse length 1, side lengths are root 2 over 2, and the angles are both 45 degrees. So, how does that fit into the unit circle? Okay, so there's our unit circle right there. There's that special triangle. Now, sometimes this triangle is shown a different way. If you multiply all the side lengths by a constant, you get the exact same shape, the exact same angles. It's just a triangle that's twice as big. And if you multiply each of these side lengths by 2, you get root 2, and 2. But that's not going to work for our purposes. We want something with a hypotenuse of 1. Okay, because we want to fit this into the unit circle. So this is the version of this special triangle that we will be using. So 45 degrees is halfway to 90 degrees. So this is our triangle right here, okay, where this is 45 degrees. So this is side length 1. These two side lengths are root 2 over 2. That's the height, right? The base is also root 2 over 2. So what are the coordinates of this point here? Well, the x and y coordinate is the same, root 2 over 2 and root 2 over 2. And that corresponds to which angle from the positive x-axis? 45 degrees. So that is a special point on the unit circle. Now, we can fit this triangle in other ways by just creating a mirror image, right? So here's a mirror image, a reflection along the y-axis. Okay, same triangle, right? This is 45 degrees right here. So what's the coordinate going to be? Well, the y-coordinate is going to be exactly the same. The x-coordinate, it's just the reflection, so it's just going to be the negative of this x-coordinate right here. So it's going to be negative root 2 over 2, and then the y-coordinate the same. Positive root 2 over 2. What angle does that correspond to? Well, we've got this 90 degree angle plus another 45 degrees here. So that's going to be 90 plus 45. This is 135 degrees. How do we know that this is 45 degrees? Well, because this is 45 degrees, and when we add this, we should get another 90. 45 plus 45 is 90. Now, there's another way we can reflect this and fit that same triangle in the unit circle again, right here. This angle, 45 degrees. What are these coordinates going to be? Well, again, the base and height of the triangle is exactly the same, but now we're working with the negative y-axis and the negative x-axis. So both coordinates are going to be negative. And what angle are we working with? Well, I'm just going to switch colors here so it's easier to see. We've got 180 degrees right there, plus another 45. 180 plus 45 is 225 degrees. 225 degrees. And there's only one other way we can fit this triangle on the unit circle, and that is like this. There's our 45 degrees. I'm just going to point to the same 45 degrees here. And of course, the magnitude of our coordinates is the same, but now we're working with the positive x-axis, so our x coordinate is going to be positive, but we're still in the negative x-axis. So our y coordinate is going to be negative. And that's how we get these 4 special points on the unit circle. It's really just one point reflected a bunch of times. We're just fitting this one triangle in there in different ways. X value root 2 over 2, y value root 2 over 2, right? That's why sine of 45 degrees is root 2 over 2, and cosine of 45 degrees is also root 2 over 2. And just through reflections, this coordinate changes where some of the components become negative sometimes, okay, based on, are you on the positive or negative x or y axis. So that's one of the special triangles. There's one more, okay? The other special triangle comes from this, okay? Consider a triangle which is equilateral. All angles are 60 degrees, okay? Equilateral, all the angles are the same, and all the sides are the same. Side length 1, right? Now, what if we cut that triangle in half? What happens? Well, this angle gets cut in half and becomes 30 degrees. This is 90 degrees. This side length gets cut in half and becomes 1 over 2 instead of 1. So what are we left with then? We have a right angle triangle. Hypotenuse is 1. The base is 1 over 2. This larger angle here is 60 degrees, and the smaller angle here is 30 degrees. And we have this one other side length to figure out. Okay, so let's figure it out. By Pythagorean theorem, 1 over 2 squared plus a squared should equal 1 squared. So we'll rearrange that. A squared equals 1 squared minus 1 over 2 squared, which equals 1 minus a quarter, which equals 3/4. Okay, so a is the square root of 3 over 4, which is root 3 over 2. So that's our second special triangle. Right angle, short end is 1/2, long end is root 3 over 2, and the hypotenuse is 1. Now again, if you multiply all the side lengths by 2, you get the exact same shape, same angles, but the triangle is just twice as big. Okay, and what that will look like, if we multiply each side length by 2, the 1/2 becomes a 1, root 3 over 2 just becomes root 3, and 1 becomes 2. And sometimes this special triangle is presented in this way, but we want to use it in this way because, again, we want the hypotenuse to be 1 because we want it to fit in the unit circle. So how are we going to fit this in the unit circle? There's the unit circle right here. There's our 30 degrees. Okay, so there's our long end, root 3 over 2. There's our short end, which is 1 over 2. Hypotenuse is 1, of course, because it's the unit circle, right? The radius from center to the edge, right? The radius has to be 1. So what are the coordinates of this point? Well, the x coordinate, root 3 over 2, and the y coordinate, 1 over 2. Okay, and that's why cosine of 30 degrees is root 3 over 2, and the sine of 30 degrees is 1 over 2. And that's one way we can fit this triangle in the unit circle. Now, the previous triangle that we looked at, okay, we fit it one way and then we did some reflections. This other triangle, though, there's actually another way we can fit it in the same quadrant, which is like this. Where, again, this is 30 degrees, and this height here is root 3 over 2, and the base, or the top, is 1 over 2. So what's this coordinate going to be? Well, now our base is 1 over 2, so that's our x coordinate, and our height is root 3 over 2, and that's our y coordinate. So our x and y coordinates actually switch. So there's two ways we can fit this triangle. Right, now the first way we fit it, that of course corresponds to 30 degrees. That's this angle right here. The second way we fit it, the angle from the positive x-axis is actually 60 degrees, okay? And that's because we know this is 30, right? And we know this is 30, which means this additional part here also has to be 30, because 30 plus 30 plus 30 is 90. And this, of course, the full angle here is a 90-degree angle. So this corresponds to 60 degrees. So these two ways to fit this second special triangle, that is what we're going to reflect. Okay? So just going to draw that unit circle fresh so that we can more clearly draw these, right? So there's the first way we fit it. There's our 30 degrees, right? So we have our x-coordinate root 3 over 2, our y-coordinate 1 over 2, corresponding to 30 degrees. And then we have the other way where it's 1 over 2 as the x-coordinate, root 3 over 2 as the y-coordinate, and this of course corresponds to 60 degrees. So now let's do our reflections. Okay, we'll first reflect along the y-axis. Okay, so the y-coordinate is the same, the x-coordinate is reflected, so it becomes negative. So we have negative 1 over 2 and root 3 over 2. And this is 90 degrees plus another 30, right? So that's 120 degrees that corresponds to. Now let's reflect the lower triangle here. Okay, so just like this, except the x-coordinate is reflected. Negative root 3 over 2, positive 1 over 2. What angle does it correspond to? Well, this is 30 degrees here, right? The whole half circle is 180, right? So 180 minus 30 is 150, right? This is 150 degrees. All right, now let's reflect it to the bottom. Okay, so now we're working with both the negative y-axis and the negative x-axis. So both of our coordinates are going to be negative. What angle are we talking about here? Well, it's 180 plus another 30, right? So that's going to be 210, right? 180 plus 30, 210 degrees. Now let's reflect this top one, right? So our x-coordinate is the same, negative 1 over 2. Let me just fix that. Negative 1 over 2. But our y-coordinate is also negative now, negative root 3 over 2. And what angle does that correspond to? Okay, well, this is 90. Let me change the color here to make it a little easier to see. This is 90, this is another 90, that's 180, right? This is another 90 on top of the 180, so that makes it 270 minus 30 degrees, because that small angle, remember, that's 30 degrees. So 270 minus 30 is 240. Okay, so that corresponds to 240 degrees. And there's one more quadrant here to do reflections in. Okay, so this reflection here. Okay, so same y-coordinate, negative root 3 over 2, but our x-coordinate is now positive, right? We're on the positive x-axis. So that's going to be a positive 1 over 2. What angle does it correspond to? Well, that's that 270 plus another 30 degrees, so that's actually going to be 300 degrees. And one more reflection, this one right here. So just like the first coordinate we drew, except our y value is negative because we're on the negative y-axis. The angle that it corresponds to, well, the full cycle is 360 minus this 30 degrees here, so that's going to be 330 degrees. and that's it. Okay, so it looks like a lot. It looks like we have many triangles here and many different points along the unit circle, but it's just one triangle placed in that first quadrant right there, and it's reflected a bunch of times. Okay, and then we have the other special triangle placed just once in this quadrant and reflected a bunch of times. So there really isn't a need to memorize the whole unit circle. Okay, you can derive it. All that what we talked about can be derived just from understanding where the unit circle comes from, where those triangles come from. But what it comes down to is you've got three triangles. This is 30 degrees with coordinates root 3 over 2, 1 over 2. This is the same triangle positioned in a different way with coordinates 1 over 2, root 3 over 2, and it corresponds to 60 degrees, whereas this one corresponds to 30 degrees. And then you have the first special triangle we talked about, which corresponds to 45 degrees, and its coordinates are root 2 over 2, root 2 over 2. And of course, that corresponds to 45 degrees. Everything else is just reflections of these in the other quadrants. And if you want to use radians instead of degrees, well, so this direction here is still 0, or the full cycle, which is 2 pi radians instead of 360 degrees, which makes half of the circle pi, right? So instead of 180 degrees, it's pi radians. Quarter of the circle, half of that, which is pi over 2, and then half of 90, well, that's our 45 degrees. That becomes pi over 4. Okay, 30 is 1/3 of pi over 2, 1/3 of 90, so that becomes pi over 6. And 60, well, that's 1/3 of 180, so that becomes 1/3 of pi, pi over 3. And to find out what the corresponding radian angles are for all those reflections, then just like we were adding and subtracting the angles in degrees, you can add and subtract angles in radians to find the radian angles there. Okay, you can always also just take the degree amount, divide it by 360, multiply by 2 pi. So I hope that helps understand the unit circle, and I'll see you next time.